in the following problem, which is a much more sophisticated version of Kirchhoff's law. Compute the current through each branch of this circuit. Alright, so let's basically, this is a multiple branch circuit. Let's say this one is going to be, I'll call this one I. That'll be circuit number 1. And I'll do another circuit here, which will go all the way around on the outer loop of this one. I'll call this another, and then I'll complete one more, which would be the same thing again. They'll go around the inner one. Okay. I'll label this one as number 1, number 2, and number 3. Okay. And around each one of these, I will basically label the current. So this would be I. This here, I2. Right. This will be a joint junction here. There'll be I3, I4. They join again here, I5, and then it goes around. All right. Okay. So one thing that we can state immediately is that at these junctions here, and at this junction here as well, and of course, this I should be careful. So that's I2 going this way, right? And then I1 going this way. Right. So at this junction here, I is equal to I1 plus I2. Okay. At this junction here, I2 is equal to I3 plus I4. At this junction here, I3 plus I4 is equal to I5, right? And basically it becomes obvious from this statement here that this implies that I2 is equal to I5, right? Which completes everything. Okay, so if we do this, let's basically draw the I1 circuit first, right? So this again, it's minus 12, right? Because we're going positive and negative. Remember, the positive currents are flowing in our circuit diagrams. There's a potential drop across here, minus 6I across that way. And there's a potential drop here as well. This is going to be again minus 6 going across this circuit here, and across this one, minus 12I. Okay, this is equal to 0. Okay, now let's do this second circuit here. Okay, so going around again. So this circuit here will be number 2. This will be number 1, 2, minus 12, minus 6I. Okay, now I don't go minus 6. I now hit I2, and I2 goes around here, so it'd be basically be I3 minus I3 times 12. That's this circuit up here. Okay, I5 is I2 again, so it'd basically be minus 12I2. Come back here. This will be a plus 12, right? Because it's going across negative positive. Going across this 12, this is going to basically be again now minus 12I2. Keep going, minus 12I equal 0. All right, and we're done. Okay, so again, we're both, I should mention, we're both starting from this point again. Number 3, let's start this again. Again, it'll be minus 12 going across, minus 6I. Okay, now rather than going I3, I'm going I4 now. Minus 12I4. Okay, and then minus 12I2 plus 12. You could just go through the rest. Minus 12I2 minus 12I equals 0. All right. Okie dokie. All right, so let's basically just do this now. Now the first thing we're going to recognize, all right, is that we've previously solved this example here, right? So what this means is that this is minus 18 minus 18I equals 0, which implies that I is equal to minus 1. So again, the current for I is flowing in this direction, right? For 1, coming up this way. Now, on the other hand, right, if we now look at this second circuit here, right, what we'll notice is that we have this one, and this one in common with this, right? So we're going to subtract 1 from 2, right? So to basically show this more clearly, what I'm going to do is I'm going to write this one out again. Minus 12 minus 6i minus 12i3 minus 12i2 plus 12 minus 12i2 minus 12i equals 0. Now I'm going to subtract from this one this equation, minus 12 minus 6i minus 6 minus 12i. So subtracting these two, this one will cancel out that one. This one will cancel out that one. That one will cancel out this one. This becomes a plus 6. So what I have left is 12 minus 12i3 minus 12i2 plus 12 minus 12i2, and then this is now a minus 6 plus 6 equals 0. All right. Okay. So now we need a relationship between i3 and i4, right? And in order to get that one, what I will do is I'll do another loop right here around. Okay, so I'll call this number 4 here. So the fourth loop, I should show you that, sorry. The fourth loop is going to be, so go around here, this will be 12 minus 12i3 plus, now because I'm going the opposite, 12i4 equals 0. Right, and so what this basically gives you is that i3 is equal to i4. Okay, that's very nice. All right, so now let's basically try to finish this off. Right, so because of this equal i4, I know that i2 is equal to i3 plus i4. So this basically means that i3 is equal to i2 over 2. So take this thing and stick it into here. Right. Okay, so let's put this together. So this is basically minus 12 i2 over 2 minus 12 i2 plus 12 minus 12 i2 plus 6. Okay, this is equal to 0, but this is also equal to, this is 6. So it's minus i2 minus 6 minus 12 minus 12 again, right? And then this is equal to plus 12 plus 6 is 18, right? So this is 12, 12, this is minus 30. So minus 30 i2 plus 18 equals 0, or i2 is equal to, you can see 18 over 30 is just see 9 over 15. Divide by 5 again, actually, is 3 over 5. Okay. All right. That's very, very nice. All right. So now let's basically look at this thing, which is 0.6. All right. Okay. So we're basically done, believe it or not. Okay. So let's basically plot the circuit here. So I is equal to, and this branch of this circuit is going to be equal to minus 1, right? And then I2 is equal to 0.6. We know from up here that I is equal to I1 plus I2, which implies that minus 1 is equal to I1 plus 0.6. So that means that I1 is equal to basically minus 1.6. All right. And then, of course, I3 and I4, they're the same thing, right? They're given by I2, so this is equal to 0.3. Okay, and so basically you have the branch here, all right, is going to be the branch here is going to be what is it? So this branch here is going to be minus 1, right? I1 on this circuit here, this circuit really is I1 is equal to I plus the current flowing through this branch is really just going to be I1 plus I, all right, which in this case is I1 plus I is 0.6, and then 12 and then I2 is also 0.6 as well. All right, hope that was helpful.